In this video, we're going to use triangle theorems to solve problems. The first triangle theorem in Euclidean geometry tells us that the angles in a triangle add to 180 degrees. It's called the Angle Sum Theorem. So an example of that would be if we have angle F is equal to 32 degrees, angle E is equal to 102 degrees, and we want to find angle D. So we have the equation, the measure of angle D plus the measure of angle E plus the measure of angle F equals 180 degrees. We could substitute in the ones we know, add them together, and then subtract that from 180, and we could find the measure of D equals 46 degrees. Next, it has to do with equiangular triangles. Each of the angles of an equilateral triangle has a measure of 60 degrees. Well, if we know that it's an equiangular in equilateral triangle, that means that all the angles are supposed to be equal. So that means all of those three angles have to be equal and add to 180. So there's three of the same angle that equal 180. Well, that's like saying we have 3 times x equals 180. So we know x is 60. So each one of those angles is 60 degrees. And that's for every equilateral triangle and equiangular triangle. Next is for right triangles. The acute angles of a right triangle are complementary. Remember what that word complementary means. It means that those will add to 90 degrees. Well, if we had that the measure of angle A plus the measure of angle B plus 90 degrees equals 180, which is all three angles equals 180 degrees, if we subtracted 90 from both sides, that means the measure of angle A plus the measure of angle B equals 90 degrees. Well, that's proof that those two acute angles have to be complementary. That's the definition when those two angles add to 90 degrees. Now, from here, we will substitute the measure of angle A as 4x minus 3, and angle B is 5x plus 3, and actually find what x is and find the measure of each acute angle. I'm leaving it to you to solve for those measures. Next, in a triangle we have interior angles. And then if we extend a side, which means I make a line that makes that side longer, the other angles that are formed outside of the triangle are called exterior angles. So we have an exterior angle here. If I were to extend the side out this way, I could have an exterior angle here. I could also extend this side out and have an exterior angle here. Here's another illustration to show you where those exterior angles would be. So we would have an exterior angle here, exterior angle here, here, and here. Notice how these exterior angles are vertical to one another, and the same here. Now, the exterior angle theorem states that the measure of the exterior angle, so the measure of angle 3, is equal to the sum of the measures of its two remote interior angles. So let's talk about what remote interior means. Remote interior are the ones inside the triangle that do not touch angle 3. So angle 3 is outside here. The angle that's adjacent to it is the blank angle inside the triangle, and the two that are non-adjacent to it are the remote interior angles. So 65 and 52 degrees are the two remote interiors. Well then, according to the exterior angle theorem, angle 3 will just be the sum of 65 and 52. So the measure of angle 3 is 117. We have the Isosceles triangle theorem that states the base angles of an isosceles triangle are congruent. First, let's talk about what the base angles of an isosceles triangle are. So I have this green isosceles triangle over here. Let's look at what the parts of an isosceles triangle are. We have the two congruent sides. The angle that is included between the two congruent sides is called the vertex angle. So the vertex angle of this isosceles triangle is here. The base is the side that is opposite from the vertex angle. So this side right here is the base. The angles that are on the base, so the angles that include the base are the base angles. So these two down here are my base angles, and the isosceles triangle theorem says that those are supposed to be congruent in an isosceles triangle. So here we have our two congruent sides. The ones that are across from those congruent sides are the base angles. Therefore, 2x plus 54 and 4x plus 38 are congruent angles. So we would set them equal to one another and then solve for x. I'd like you guys to find the value of x and then find the measure of each angle, not just each base angle, but also go ahead and find the vertex angle up here. This last example I'm going to leave to you guys. You're going to find the measure of angles 1 through 5 and justify how each was found. So each angle you find needs an explanation. So that explanation would include a theorem that you possibly used. And you might just use not just the triangle theorems, but theorems such as the vertical angles theorem and the linear pair postulate. So keep in mind that there are still those relationships in play even though we're talking about triangles.